Okay, grade 11s, we're looking at trigonometric identities. These are things that you're going to apply to manipulate expressions, equations, whatever it is that you're working with. So this is a tool to you. Our first set of identity, or the first identity I want to do with you is the square identity. Now the square identity says the following. It says the sine squared of an angle theta plus the cosine squared of an angle theta is equal to 1. Okay, now let's see where that comes from. If I go back to my right-angled triangle as an illustration, that's theta, so I'm going to call this ABC. Angle B is the right angle, that's small side A, that's small b for the side, and this is side C, opposite the angle C. Now let's do what this tells us to do. What is the sine squared of theta? Here's theta. Sine is opposite over hypotenuse, so it will be A squared over B squared. And let's see what cosine squared would be. Cosine squared of theta is adjacent over hypotenuse, so it's C squared over B squared. Remember, if the sine of theta is A over B, the sine squared will be A squared over B squared. Okay, let's see what we get now if we add them. We get sine squared theta plus cosine squared theta will then be A squared over B squared plus C squared over B squared. The denominators are the same, so we can write everything over B squared. Now look at that, A squared plus C squared at the top. Now you can remember that Pythagoras said that in a right-angled triangle, the sum of A squared and C squared is equal to the hypotenuse squared. Okay, so this is equal to B squared over B squared, and that is by Pythagoras. Okay, look at that, B squared over B squared is indeed 1. So the sine squared cos squared is equal to 1. Okay, our second identity that we're going to look at is called the quotient identity. Okay, now quotient is something divided by something. Okay, and that identity says that the tan of theta is equal to the sine of theta over the cosine of theta. And let's now go and draw on the same triangle. We've read off the sine of theta. The sine of theta, we've got sine of theta is A over B. The cosine of theta is C over B. Okay, let's see what we get if we divide those two. The sine of theta divided by the cosine of theta is A over B divided by C over B. Okay, folks, we see immediately that we are stuck here with a complex fraction. Now, if I want to get rid of that complex fraction, all I need to do is multiply the top with a b so that those can cancel. But if I multiply the top with a b, I have to multiply the bottom with a b. Now, in effect, you're multiplying with 1, so you're not changing the value of this thing. Okay, it's a clever trick. The b's cancel, and at the top, I will be left with an a, and in the denominator, the product of those two, the b's cancel as well, so I have a over c. Okay, now let's go and see what is the tan of theta. The tan of theta, in my right-angled triangle, tan is opposite over adjacent, which is a over c. And you can see that the sine over cos is a over c, the tan is a over c. Therefore, with all of this, we can say the tan of theta is indeed the sine of theta divided by the cosine of theta. Now, folks, you've got to know different variations of this form, of these two identities. First of all, the square identity, and then your quotient identity. So let's look at different variations. If we know that sine squared theta plus cos squared theta is indeed a 1, then from that we can write down quite a few other forms of exactly the same thing. This would mean that the sine squared of theta by itself, if I throw the cosine over the equal sign, is 1 minus cosine squared theta. And from that we can get to the sine of theta by itself. The sine of theta by itself is equal to plus or minus the root of 1 minus cosine squared theta. Remember, you're taking the square root both sides, so don't forget the plus or minus. Now, in this case, we're working with an acute angle inside a triangle, okay, and we've learned in previous video clips that all angles that are acute lie in the first quadrant, and hence the sign of that angle will only be positive. But I'm looking at a general manipulation now. So this is for theta in general. I can also write down the cosine squared of theta as a variation of the square identity. I throw sine over, I get 1 minus the sine squared of theta, which again also breaks down to the square root both sides. It breaks down to 1 minus sine squared of theta. Those are different variations of exactly the same square identity. Okay, now let's look at the second one. The second one is very, very useful. I'll come back. Now let me complete this one here. Sometimes we are required to factorize this when we work with identities. So just to remind you that you learned that a squared minus b squared is a minus b, a plus b, the algebra form of difference of squares. So 1 minus cos squared theta can break into two factors. It decomposes as 1 minus cos theta, 1 plus cos theta. And the same for sine. 1 minus sine squared theta decomposes into the two factors via this rule as 1 minus the sine of theta and 1 plus the sine of theta. So all of these things are different forms of exactly the same thing, folks. Don't forget that. This here, you have to remember, you have to identify more algebra when you do trigonometry than what you're going to use trig in itself. And I'll show that to you in a later video. Okay, let's go for this quotient identity. The tan of theta, we've seen, is equal to the sine of theta over the cosine of theta. Now what makes sense here for me to do is to just manipulate my fraction. So if I want to write down a different form of this identity here, then all I can do is multiply the cosine across. So I have the sine of theta is also the cosine of theta multiplied by the tan of theta. Now folks, this is a form or a different version of this quotient identity that's going to pop up in your life quite often. And if you identify it, you make your work so much easier. Okay, of course we can say then, if we take cos across, we can say another form would be the cosine of theta multiplying to this side and tan dividing to give us the sine of theta over the tan of theta. We are hardly ever going to do this. We're not going to turn a cosine into the sine of theta over the tan of theta, because that is deliberately turning something that's not a fraction into a fraction. Okay, at most, this is what you're going to apply. But what makes it quite nice is if you know these various forms, you can identify them and use them in your identity proving. If you see a sine over a tan, you know it's going to be a cos if those two angles are the same. By the way, I forgot to say that to you, that in all these identities, you can see I used the same angle. So for the identities to be true, you have to have the angles the same. So the sine of 10 over the cos of 10 is the tan of 10 degrees. Okay? The sine squared of 25 degrees plus the cosine squared of 25 degrees is always 1. Those angles have to be the same. Now please know your identities, know their different forms or their different variations, and you will see it will make your life so much easier when you prove identities.